Hello, welcome to another episode of the Prof series. For this episode, we'll be covering the researchers Dr. Bill Deen, Dr. John Lauzon, and Dr. David Hooker. Bill Deen is a researcher at University of Guelph, recently retired. He's a specialist in cropping systems, which is the management of crops, crop rotation, and the different techniques that can be integrated into a farming system. Cropping systems is basically the jack-of-all-trades, master-of-none field of agricultural research. Dr. John Lauzon is a researcher at the University of Guelph as well, and a researcher in soil science, teaching both soil science courses within the University of Guelph. And Dr. Dave Hooker is a researcher at Ridgetown campus, who also teaches many different courses, cropping systems, intro to agriculture, and several others. His work is in crop physiology, which is the study of the physiological aspects of a crop and what makes it high-yielding and highly suitable to a farm environment. In this episode, we'll cover a paper by all three of them regarding the use of nitrogen rates and fungicides within wheat. This paper was written in 2014. Let's get started. The demand for wheat has always been increasing, but it was increasing faster than the genetic gains and yield potential, as well as being faster increasing than the actual price for the cash crop. In Ontario, the common rotation is corn and soybean. Growing corn, soybean, and wheat altogether actually increases the yield of all three, but the yield is still not there for it to be economically viable, and in many cases, same thing goes for the price. During this research paper, it was realized that, at the time of this research paper's development, nitrogen rates were based on research that was performed over 30 years ago between 1970 and 1980. But since then, new technologies and equipment, as well as new chemical additives, have been added into conventional farming. So the question of whether or not nitrogen rates can be shifted in response to these new conditions was asked. Other papers in different countries showed that for newer cultivars, there was a gradual increase in the N being a shorthand for nitrogen in farming circles. There's an average rate of 2.8 kilograms per hectare requirement increase per year, corresponding with a 0.098 milligram per hectare per year increase in yield. There's also the question of lodging. As you increase nitrogen, you increase the chances of lodging. With more dwarf varieties, the risk is less, but there's still a point when you fertilize it too much and it lodges, which is where the crop falls over. This creates an environment where fusarium can affect the crop a lot easier, and increase the amount of mycotoxins, which are the toxins produced by the fungus within the grain crop. So to figure out what the best way to deal with this situation is, different fertilizer rates when it comes to nitrogen and different fungicide regimens were tested out. The nitrogen rates tested were 100 kilograms per hectare, 135 kilograms per hectare, and 170 kilograms per hectare. Within this framework, there's also treatments tested. The control group without fungicide, the second group, which had one round of fungicide between growth stage 28 and 30, or the late tillering stage. The third fungicide treatment was the fungicide was applied between growth stage 35 to 40, or the flag leaf stage. The fourth fungicide treatment occurred between growth stage 60 to 65, or when the flowers were finished doing its thing. Fungicide treatment number 5 was one spray at growth stage between 28 and 30, and another between growth stage 35 and 40. Treatment number 6 on the fungicide level was one fungicide round between growth stages 28 and 30, and one fungicide round between growth stages 60 to 65. Fungicide treatment number 7 had one round of fungicide sprayed around growth stage 35 to 40, and a second one between growth stages 60 and 65. And treatment number 8 had one round between growth stages 28 and 30, another round between growth stages 35 and 40, and a final round between growth stages 60 and 65. 8 different cultivars were tested. 3 are moderately susceptible to fusarium. 3 were susceptible to fusarium. 1 was highly susceptible to fusarium, and 1 was moderately resistant to fusarium. As for the rest of the diseases, there is variation between the 3 common diseases: septoria, powdery mildew, and leaf rust. The use of plant growth regulators was also tested out within this experiment. This experiment occurred over the course of 3 years. Now here are the results of this experiment. First, during the high nitrogen rate, 170 kilograms per hectare, the plant growth regulator added reduced lodging, but only at Ridgetown sites. Those that are more prone to lodging did not have reduced lodging under this treatment system. Little difference in yield occurred within all systems, however, when it came to plant growth regulators, primarily because lodging was relatively low in both areas, indicating that many of the modern cultivars have more lodging resistance than people expected. The interaction between fungicide and nitrogen was also studied. There seems to be a synergistic effect between nitrogen and fungicides was found to be real. At 170 kilograms per hectare of nitrogen led to a yield of 218.79 bushels per hectare. With the addition of fungicide, this yield rose to 251.1 bushels per hectare. This occurs only with the most intensive fungicide application strategy, which involves spraying the fungicide 3 times in a season. The addition of 3 rounds of fungicide spraying would add about 32.3 bushels per hectare on average. The most economical method, however, was 2 sprays, one at between growth stage 35 and 40, and one at between 60 and 65. This adds an extra 4 bushels per acre, not as much yield as you would get if you sprayed 3 times a year, but far more economically viable, based on current research calculations at the time of this paper. From a yield perspective, the maximum amount of yield occurred somewhere between 100 and 170 kilograms of nitrogen per hectare. Yields declined at the highest rate without the add of fungicides. The effect of cultivar also has a major effect on the effectiveness of the fungicide and what yield is added to the mix. The moderately resistant variety yield more in combination with the fungicide than the moderately susceptible variety did. So the pattern is this. In an intensive fungicide system with heavy amounts of nitrogen, if you select a moderately resistant cultivar to most diseases, and combine all these treatments together, you will get an overall increase in yield. And that about covers everything. Thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.